I'll get started in just a minute. I'm just gonna pause. Looks like things are going. Pause my playback streams. Say hi in the chats. Hi DCD, I see ya. Hope everybody had a good week. Can you hear me? Is that okay? Hi, Mark. All right, I think we're going. I don't think I forgot a step. We'll see. So hello, everyone. My name is Scott. I go by Tanya Online, and this is a deep dive. So I deep dive every week that I'm working on the work that I'm doing for CircuitPython. So CircuitPython is a version of, hi, thank you, Digit. CircuitPython is a version of Python designed for little tiny computers called microcontrollers. I happen to have this Metro RP2350 board on my desk, so I'll show that to you. So this is a development board that Adafruit makes. So Adafruit is the folks that you're watching. That's their channel. They make little devices like this, and they pay me to work on the software that runs on these little tiny computers with the goal of making it super easy for you to program to do whatever you like. So that's CircuitPython and Adafruit. If you want to support me, go to adafruit.com, purchase hardware there, and they pay me to work on this stuff and stream and stuff. So hello, Beata. Sound level seems fine. That's good. So Deep Dive is a stream that happens every Friday. I do it a lot, but also Tim, aka Foamy Guy, does deep dives a lot, especially because I've had 2 kids. So in a few weeks, Tim will hopefully be taking over. I haven't actually checked with him. While I'm on the rest of my paternity leave for my 2nd kid. So thanks in advance to Tim, who always fills in for me. It's super awesome to keep the deep dive spirit alive. So this is just usually whatever I've been working on in the week, kind of where I'm at and just whatever I'm working on. But it's also a really good time. I'm not a great documentarian. Not great at documenting things. So this is a perfect chance to ask me about CircuitPython stuff or other stuff, and I'll try to answer it. To me, it's also kind of like office hours, where like if people have questions, you're welcome to ask them. So that's what a deep dive is. It's about 2 hours, so we got plenty of time to go on plenty of tangents, as you probably know from watching me do this before. So does anybody have questions while I put some hand lotion on, and otherwise I'll dive into what I've been working on, which I'm quite excited about. And it's at the bottom of CircuitPython. And something that MicroPython may want to, which I'm very, very interested in. I see Mark's typing, so I'm going to wait. Question about your leave. With Jeff retired, is there any plan to help with the PRs during that time? Or just hope the community can step up, which I get I'm one of them who can. So I guess what I should say is, so Dan will be working while I'm on leave, although he does have a vacation at some point. Hi, Hams Labs. And we actually started paying ADCC as well. So ADCC is doing some hours for Adafruit too. So the hope is that he'll be able to help too. So it won't just be Dan while I'm on leave. And hello, ADCC. Very interested. Okay, so let me set the scene. And Mark, I hope that answers your question. So yeah, and it's important actually, I should say about leave. So I have 8 weeks completely off, and then I will be part-time. My plan is to be part-time until my youngest goes to daycare at like a year. So she turns a year at the end of October. So like hopefully daycare in November. But yeah, I'm hoping like those part-times I'll still be around. I just won't be doing anything super big. Yeah, didn't want Dan overwhelmed. Yeah, I think you will find, and you should expect us to be doing kind of more maintenance mode than ambitious things. We've talked a little bit with Dan about kind of things, Dan and ADCC, like what things we could do kind of while I'm out. And we've got ideas too, but I think generally it's going to be like more maintenance mode stuff. But I would like to see 10 get out even if I'm on leave, because like I think, you know, that's kind of a free benefit for people. If we can move the 4 megabyte Espressifs over to where they have BLE, that would be good. Thanks, Mark, for the offer for doing reviews. That's super helpful. And hello, C. Grover. Okay, so let me set the scene. So DCD asks, so is FruitJam OS resting? So I started there, and I've kind of gone down a path. So let me lay out the path. I don't have it set up to kind of tell you, although you know what, I do have some videos. They're not going to be great to play, but I could try to play them. So if I go, sorry, I know I'm not showing you my desktop yet. Okay. The playback quality may not be great for you. So this is a capture I did of the boot up animation. If you watched Foamy Guy's streams, he did a boot up animation based on Bruce, our designer's kind of potential boot up animation for FruitJam. And I think that's what this is a recording of. Let me put my headphones on so I can hear it. I want to hear it. I want to hear it so I can this one doesn't have the problem as bad. Hi, Timon. You sent me down a rabbit hole. The LVGL font rabbit hole. Okay, this might be... Okay, I'm going to turn the audio on for a little while. Hopefully it's not too loud. I'm going to turn the desktop audio on so you can maybe hear this animation. But yeah, so another optimization that I have to do that is on the back burner is that I realized that the terminal tile grid is updated in the background even if it's not displaying. And with the LVGL font stuff, it is like much costlier if you hit a character that you haven't loaded. So one thing I also want to do is disable that while it's not on. Okay, let me turn the audio and I'll play it with the sound. I did end up implementing their format. It's in bitmap font as well. Okay, so there's a couple bugs that got captured in this, and I'm kind of glad I did take this recording. So this recording is actually, the bottom of it is the capture, and then the top part is the capture of the Salier window as it goes along. And I added like logic pin highs around like when display is doing something, when audio is doing something. And then I saw these like huge gaps of like 120 milliseconds and was like, like what is happening in this gap? And like you can hear the, yeah, so there were some really bad crackles that are even worse than what's in this video, but they totally line up with these 120 millisecond gaps that I was seeing, which turns out to be garbage collection time. And then of course this animation, did the animation work in this video? I don't even remember. So the animation didn't used to work with, play it again. Right, so in this video, the letters don't even work. So there was one bug that I found that's it works fine without the audio, and then if you add the audio in, the display stops working. And that was because the audio buffers that get DMA'd out were getting allocated into PSRAM. And PSRAM is much slower than internal SRAM. So a change that I already merged in, that got merged in and it got PR'd and merged in, is to place those critical audio buffers that get DMA'd into internal SRAM. And once you do that, you're able to have both show up concurrently. That's what the newer video shows. And in fact, I think I have a third video. Let's see what the third video is. Okay, audio's off. I'll turn audio back on. Okay, so unfortunately I can't like zoom in on the Salier trace, but basically like the most egregious audio sounds were the GC happening. So Mark says I should try and fix that with the whole audio effects chain, though I don't think I have a PSRAM board at the moment. So it's only really bad for DMA because the DMA, so the DMA is also being used to output the video. And if you DMA from PSRAM, it works, like the audio did play, but it basically like absorbs a ton of DMA time because the fetch for the DMA has to stall. So whereas like the DMA can do one fetch of data per cycle, that's only if the data comes back to it in one cycle, whereas with the PSRAM is not always the case. So that was an interesting bug, and I fixed that. So now on the now in the RP2 port, the Python VM will be put into PSRAM because so there's this port malloc call that says, do you need to be DMA capable or not? Which we totally used to just ignore and just use TLSF to allocate it. Now we actually say, if you say you don't need to be DMA capable, like the Python VM says, we'll stash it into PSRAM immediately. And only if we can't allocate into PSRAM will we allocate to internal SRAM. Or if you say you need DMA capable, we'll put it into SRAM. So that's been fixed, and that fixes the audio, so you can get both of them showing. And I guess I should show it. I'll just show the animation. This is the last one I recorded. Another thing I meant to look at that I didn't even get to was that I was putting logics like pin highs every time the frame buffer, the HSTX stuff gets reset. And it's actually doing 80 frames a second instead of 70 like the mode says. And this is, I think, an artifact of us not doing the correct pixel clock. So one thing I was thinking about looking into is like extending the v-blank time so that we basically like, instead of lowering the pixel clock, we just extend the v-blank time to get the right frame rate. So yeah, so that got me thinking about memory placement. And the way that I fixed it was the audio thing that needs to say that it's DMA capable. It just allocates the buffer with port malloc instead of the VM's mallocs, because the VM mallocs you do will now be non-DMA'able. And then that got me thinking, well, 120 milliseconds is a really long time. Like, what exactly or why exactly is that? And I prototyped it yesterday, and I talked with Bob about this too. But what I did is I said, hey, like, for bitmaps. So we're doing a lot of bitmap stuff, right? We load bitmaps into memory. They don't get DMA'd. They just get used by displayio to put them in the buffer. You know, like, because they're not DMA'd, but they are allocated. I don't know how to say this. Anyway, I decided to do the same thing and not use the Python VM to allocate those things. Instead, I just allocated them directly to the outer heap, as I call it. And the advantage of that is that it shrinks the size of the Python VM, like significantly. So that I just added some prints, and you'll see them here for like how long the GC's like GC process takes. And it went from like 200 milliseconds for a different demo, not for that animation, but 200 milliseconds, and it dropped down to 40 just by putting the bitmaps off the VM heap. And I think it was this morning, and I was like, you know what? The problem is that the way, I know I'm not showing anything, I'm just using words, but what happens when you do a collect is that you have this collection of root pointers. You say, here's all the things that I want to make, that I'm currently using, I want to hold on to them. And then anything that those things reference, I want to hold on to those things too. So say you have a dictionary of Python objects, you say, I'm holding on to this dictionary, and then all of these Python objects also stay around, and anything that they're holding on to, because it could be another dictionary, for example. So there's this process called collection, which is like you start at some set of root pointers, and then you mark like everything that those refer to as in use, so that you don't delete them. So Python is a language where you don't have to explicitly say free. You could, or malloc really. Like malloc is implicit as well. But in a language like C, if you ever want memory, you have to say, memory allocate some bytes. And then at some point, you're going to come back and say, now free it. Whereas in Python, what you do is Python makes objects as it needs them. And then when they're no longer referenced, they get cleaned up and deleted. There's no explicit free. The way that works between CPython and MicroPython is quite different. But MicroPython and CircuitPython do what's called a mark and sweep. So you say, okay, I'm gonna do this collection process now. Let me look at my root pointers and the stack, and any right. Bob's jumping ahead. So you're saying, so what you say is like, I'm starting at all these pointers and these like places pointers could be, like the stack. Let me just recurse, and all of the numbers that look like they're pointers into our heap areas, let me recurse into those, and we'll mark those so that they don't get collected. And then after we've marked everything that we keep, we go back through that list of everything in the heap, and anything that's not been marked, we delete because we're not using it anymore. And like Bob is saying in the chat, if you do this giant bitmap, and you say, oh, I'm going to allocate this big bitmap to the VM heap, it doesn't actually know that like there's no pointers in there. They just know it's like there isn't any smarts about like which allocations to the Python VM heap you should or should not do this collection process over. So it turns out that like you put giant buffers in your PSRAM that are in your VM heap, and then you have to, every time you do a collect, you have to read over them to see if there's any pointers there. And that's just like really slow. Like there's a cache in front of PSRAM, but you're literally like going over every area. So you're gonna be missing that cache a lot because it's only so big. So this is the idea I had this morning. Is like, what we need to do is we need to change the way that we allocate memory. So this is best for items that you know will be collected. Right, so what I've done, or doing, is I'm trying to change all of the allocations in MicroPython and CircuitPython. So the parts of the code that we inherit from MicroPython and the parts of the code from CircuitPython, so that they either explicitly, which I don't really want, but implicitly say if this memory is going to include pointers that need to be collected or not. So if we look at Bitmap as an example, let me pull up Bitmap, even though I've got other stuff open. So if we go in shared module, displayio, Bitmap. So we'll actually only see one. So there's a construct from buffer and there's a construct. And construct from buffer says, if you didn't give me a data pointer, we're going to allocate it itself. Yeah, and Bob points out that this also kills the flash code accesses due to filling the XIP cache. Correct. So the cache that is in front of PSRAM is shared with the cache. It's the same cache that's in front of flash as well. So yeah, we're trashing. The more accesses you're doing, the more churn you're going to cause in this cache. For bitmaps, we do this malloc, and we just tell it like straight up we want a chunk of memory this big, and that's where we're going to store our bitmap data. There's no pointers there, but we have not told MicroPython that there are no pointers there. And so when it does this collect process, and let me just show you where that is. It's in GC. So it says it's called GC mark subtree. So you say, hey, this block is in use. Mark everything that it references. So it figures out how many blocks that is. And then this is the new thing. So CTP should scan. So before this, it would always do this process of, for every index in this, treat it like a pointer, get the area that this pointer is in. So right now, MicroPython has this notion of split heaps, which means that, oh, sorry. Hi, Krish, and hi, Ed. I had a window covering you on YouTube. So traditionally, MicroPython and CircuitPython have had one giant allocation that is the VM heap. But in CircuitPython 9 and in some ports of MicroPython, they introduced this idea of split heaps, where instead of doing one giant allocation, you can do smaller allocations and then look between them and like have allocations in those split heaps. The reason they did it, and they do it on Espressif, is that smaller heaps are faster to collect. And on Espressif, they too have an outer heap. So when I saw that feature, I was like, oh, that's really cool. We're just going to do it always. So what we do is, for ports where we don't have a real-time operating system, we actually we use the same thing that the ESP IDF does to manage an outer heap. It's called TLSF. It's awesome, and I want to do more with that. The other cool artifact of this is that we can now concurrently allocate to the Python VM heap, which has this property of being collected and swept and garbage collected. Or we can allocate to the outer heap, where you must do malloc and free. If you don't do malloc and free, you're going to leak and you're going to run out of memory. It's not going to be good. The benefit of the Python VM heap is that once the VM is turned down, it gets all erased and given back to the outer heap. So I lost my train of thought. So what I'm trying to do is I'm trying to add some notion to allocations within MicroPython and CircuitPython, whether they should be collected or not collected. So in terms of the bitmap, the outer object. So the outer objects get allocated by shared bindings in CircuitPython land. So if we go to shared bindings, displayio, bitmap, we'll see make new calls mp_obj_malloc, and it gives us the self object. So this is a C struct, and the C struct has a field that tells the VM what type of object it is. And then we pass that into construct, and construct is the thing that calls malloc for the actual bitmap, like the actual memory that holds the bitmap. So what I've done is I've tried to make mp_obj_malloc it allocates memory, it gets marked as collected. But when you call malloc, it does not. So the assumption I'm trying to make is that if you call malloc, you really mean just raw data. You don't mean pointers. If you mean pointers, you do np-obj malloc, which is a struct of a custom type that might have pointers. Or I also added this malloc items. So for a list or a dictionary, you have this wrapper struct, and then you also have a list buffer, and that list buffer is, it's either it's np-obj, which could be pointers or they could be packed data. Mark says, this stuff is always so cool, except when I had a weird frame buffer bug, I think, and was debugging in the GC. Yeah, so this, the reason I'm so excited is because we do get these bugs where people say, oh, I was thinking about this bug that Melissa filed, and I'm not sure we turned it off. But it's also caused by long GC times. I don't know if I'm going to be able to find it. But Melissa filed this issue where she did a touch paint program. And if you do a spiral, you could see points where you weren't getting any points on there. And it was because as you're moving your finger, you're generating garbage. And then when you hit a garbage collect, you get a blank spot because it's like busy collecting while your finger's moving, and around and around. So anything that we can do to improve collect times just is going to make like Python execution code like so much more pleasant, because that gap that you have. Like I've been really insistent when people want their Python code to be deterministic time-wise, because it's not. At any point you could trigger a collect. But if we can make collects faster, that's a huge win still. So being able to drop the like 200 millisecond one down to 40, I was like, yes. And that was and I did that drop just by moving bitmaps out of the Python VM. But I think I'll get similar, maybe not quite as good, but I could get like better things. GC disable, problem solved. So disable probably just removes collecting. So yeah, I'm trying to be really aggressive with this. I'm trying to actually like make some assertions about MicroPython provides a number of kind of wrapper allocation APIs, and I'm trying to hide whether they collect or not behind that. It's not working out that well for me. Because the intent of some of these is not very clear. This one's very clear. np-obj malloc is like saying I'm allocating a Python object. Here's the struct type, here's the Python type, and because it's a Python object, obviously it should be collected. But it's crashing right now. So where I'm at, it's crashing. It doesn't start up. And the reason is that I think I'm freeing some memory that I shouldn't be, right? Like, so how do yeah. So I gotta figure out how to discover the memory that I should have been collecting that I'm not collecting, and what is allocating it, and why isn't it marking it as collected. So there's this whole ambiguous family of allocation macros that are in misc. So there's mnew maybe, mnew 0, mnew obj maybe, mnew obj var 0, var maybe. So the maybe variants are ones that will not raise an exception if you fail. This is helpful for like recovering from it rather than raising an exception. The 0 means that it blanks the memory for you, always. And so you can see here that I'm trying to make mnew not collect, but I've made mnew obj var collect, but mnew obj does not collect. I don't like this naming. I would love to get rid of mnew, but it's like used in a lot of places. It's the reason it exists, I think, is because it does this size of, which makes it like convenient because you don't have to use size of everywhere. But it doesn't tell you. It tells you it's a. It doesn't even tell you kind of what its use is. There were some mnew np-obj, and so I've introduced this malloc items, which now calls my helper and says, oh, like make sure it's collected. So one thing I wanted to do is I wanted to triple check. So in malloc.c, I have my malloc helper that takes in flags. And then if this, I like to be very explicit. So if I mask it with collect and it's not 0, and that is, oh, it's fixing it for me. If it is equal to 0, then I'm going to call malloc without collect. Otherwise, I'll call it with collect. And then if this selective collect is off, because it does cost. So you are visiting all the allocations in CircuitPython. All allocations that are live, so are reachable from root pointers, will get visited, as it is today. So it does cost 1 bit per block, the way I have it doing it. So it will use more memory to do this, but I think the trade-off is going to be worth it. I'm very tempted to do a modified TLSF for all this too, because TLSF has some really nice properties like constant time allocations and freeze, and it's a good fit algorithm, so it could make allocations faster. And in this collect process, it does this like process of like it doesn't know how big every allocation is, so it has to do this kind of like loop through this metadata. It also crossed my mind to put the heap metadata in the internal SRAM and the actual allocations externally, but I'm not going to do that here. How did you manage to update the mag tag in CircuitPython? Mag tag is ESP, right? Did you try doing it with the web flasher that you can do in Chrome? That works pretty well, because I think it's an ESP. Okay, so I think I have this right. If I call malloc without collect, it goes up here and it does a gc allocation and it gives it the flag do not collect. With collect does it with it. And if you call malloc specifically, we assume you're doing the collect. Trying to save you from yourself. I think that's right. And then if we go into gc and if it's alloc flags. So I realize I should check this to see if it's. Okay, so it says if MicroPython enable finalizer, do this. If MicroPy enable select, do not collect. If do not collect, clear the bit. If it is set to collect, then mark it. So I think that's right. All right. So let's save it and rerun it. I have the debugger plugged in. I don't really trust the debugger to load correctly into Flash, which is probably my own issue. I actually prefer doing it over UF2. And then I connect the debugger after the fact. I tried to like put some debug prints, but I think I was actually like stashing pointers on the stack and causing it to work. We'll see. So I'm hard faulting after a GC, and you can see that I'm scanning some blocks and skipping some blocks. And the question is, am I scanning and skipping the blocks I should? So what I was doing is, I think what I'm going to do is just break on gc alloc and then just look at each one. So np-map init is setting the collect flag, which is not setting the allocate flag. Same place. Bob says, I really like the idea of replacing the VM allocator with TLSF. There's no technical reason I can see not to have TLSF sub heaps under the outer capability based TLSF heaps. Yeah, the TLSF good fit is really neat. Like in the quick allocation time would be really good. Okay. np-map init. So this is a list, and it's also trying to be collected. So I'm going to go until, I'm going to continue until I get an allocation that doesn't want to be collected, because that's likely going to be my problem. I should turn USB off. That's weird. Maybe I fixed it? But if I clear it and hit reset. Yeah, then it hard faults. It did the same thing. Like it runs boot.py from reset, but not. Oh, you know what? I'm probably in safe mode. This is probably safe mode. Interesting. These are allocations that are happening without safe mode? Or in safe mode? It could be safe mode. I think I set the safe mode state. I'm not doing the full. Oh, maybe we're running safe mode.py. Is that what it was? Yeah, we are. Okay. That's why we're not running boot.py. So let's just make it always start. Wait briefly. Get safe mode. Set safe mode. Where's get safe mode? Somewhere else, huh? Probably in supervisor shared safe mode. All right. All right. That's what we want. It's weird. Yeah, I don't want USB coming up. So the web, how are you getting into the ESP bootloader? You have to hold the boot button while you press reset. And that should get you into the ROM bootloader, not the UF2 bootloader. So I would use Chrome and make sure that you're doing the hold boot while you press reset. Okay, so we hard faulted. Okay, on reset init break gc alloc. Okay, so now we want to go until we see a flag that is, actually let's backtrace too. Yeah, so we're running boot.py, which is good. And let's just go until we get something that says it doesn't need to be, here we go, this one. vstring init. I think that is, let's check vstring. I don't actually know what vstring is. vstring init. So that allocs exactly the given number of bytes. So it's doing characters. That seems fine. But the outer thing does need to be allocated too. So I think this is okay to not collect because it's going to be a string. this is QString from string is doing an allocate that says it doesn't need to be collected, QString 375. Mnew maybe. MP state qster last chunk. Which I think is okay. Oh, it could be. If anything gets reallocated, I think we're going to end up reallocated and moved. We may not be copying over the state. That could be the problem as well. This one's fine. This one's fine. This one is fat VFS open. malloc maybe. VFS fat file 273. VFS fat file 273. Construct the map. CLTBL. I don't know what that is. It's probably not going to store pointers. So I think it's okay. MP Lexer new. Pi Lexer 843. See, so this takes in a reader. And my guess is the reader is heap allocated too. If we just look at it, elides reader, but my guess is that that is true. So this would be incorrect. Mnew obj. Source name is a QString, so it's not going to be a pointer. This is the problem, is I've not given myself an escape. I don't have a way to. I didn't add a with collect variant, which I could. I don't like that it's called object, really. Maybe this should just be like new struct with collect. I don't know. It's kind of annoying. Which would be this, but with. No, 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 no. No. Oh, this is the. See, object, it's just there to say that it's only one of them. I'll just go back here and say it's new struct with collect one. Okay, let's keep going because I don't think there's that many to inspect. So let's just keep looking. 853. M new UX 16's allocate indent level. That should be fine because they're V strings were already set as fine. V string map. Map is wanting to be collected, so it's fine. Parse. Parse 1046. M new maybe. A rule stack. I don't think rule stacks need to be collected. No, I'm gonna keep going. MP parse 1058. Parse node. I don't think parse nodes either. I think it's a little weird. Push result rule. The 2 means no collect. Wave file. Q string from string. Q strings. We looked at this. Qster 375 is this new chunk. I think it's fine. There's like QString tables and they're QString chunks. Sorry for the siren. I should tell you that the siren is on my end. Thought we were listening to some ambient station. Oh. Yeah, the window's open. Okay, so here we have our M re-alloc. So this is interesting. We're allowed to move. We need to fix this. Because I think, although this is a V string, but we need to take a peek at gc re-alloc. And how it maintains the other pointer. Trying to do it just like check for free. Shrink. Expand in place would be fine. Okay, so here we need my interesting. So FTB state. We actually need alloc flags. Oh, no, no, no. This is not quite right. I think you had it. You can do it. You were doing it before. I forget what the flag is called. I've gotten so lazy. There we go. And then we have to invert this because it's a little weird. Yep. Okay. So now, if we have to put it somewhere else, we have to copy that state. We have to copy that state over. Okay, so let's just keep going until we crash. Into safe mode. Let's make sure we stop then. So this is something collected, so we're not going to worry. Ooh. We don't need another breakpoint. We need to continue. MP_obs new string copy. Look, I'm loading a WAV file. Hi, Gary. Obstring 2246 probably doesn't need to be obstring. Let's just double check. Oh. M new. Yep, so that's the pointer. So the outer object is being allocated with MP_obj at malloc, which it should be. And then the pointer itself, the data, the string data, we know is not going to be a reference, so it's okay that it's not collected. This is a make node const object. Parse 549. Make node const object. Source line. Parse or allocate. I imagine that's not something we want. I don't know these allocations for parsing very well. Parse C 549. Make node const object. It's making a parse node struct. It is taking an MP_obj. So we probably do need to collect all these parser allocations. Otherwise, we'll drop these objects that it's holding on to. That's my guess. Because it's got this MP_obj that's probably... Sorry, I don't know if you heard my phone ring. I have a lot of car dealerships. A lot of car dealerships right now calling me because we just bought a car, which is exciting. Trying to avoid all the tariff stuff. So I think parse or allocate needs to be doing collecting stuff, which kind of makes sense. Renew is going to do a reallocation. Although mrenew maybe is not going to. Chunk is not null. Allocate a new chunk. I don't know why it's taking in bytes. Like, size of NP parse chunk plus the allocation. So we don't have a way to, we could just call like mark collected. Or we could do an M malloc with collect and just be done with it. It's just like so annoying. So let's go to our misc. No, we don't need to take flags. We could call it directly, actually. And it was calling mnew, but not mnew maybe, so that should be right. We want to raise an error. Okay. So now all the parser stuff should be parser allocate and reallocation. Parser allocate. I don't think we're getting out of the parser. vstring. New string copy. I think we looked at that, right? Node console object we just did. New string copy we just did. New string copy we just did. All right, let's see if it works. I'm sick of walking through that. Hey. We're doing good. We got an hour. Okay, unplug my debugger. Copy it over. It's getting further. GC took 2 seconds because you're printing. Where am I, though? Did I crash? Because the USB didn't come up. It just took forever to print. In general, will these CPU GC allocation improvements apply to MicroPython too, or are they just making the non-Python allocations more efficient? That's correct. They should apply to MicroPython as well. It particularly helps large allocations that you don't need to scan. So if you have like well, I haven't talked with the MicroPython people about this yet, so we'll see. They like to redo things their own way, but like in generic MicroPython land, like a large byte array or a large array would now be exempt from the collect process. So you'd be able to have like large buffers and they wouldn't cost you collect time or as much collect time. I don't know what's happening here. I'm going to comment out the skipping and scanning and the alloc. I want it to run quicker. Sorry. I got the second one. Skipping block. Scanning block. But this is the problem with me being ambitious, is like, I don't know that I got everything correct. This is a siren on my end again. Siren is on my side. But yes, the idea should definitely apply to MicroPython as well. I was originally thinking of it this morning as leaf allocations. So like we have root allocation, we have root pointers, and these would be leaf pointers. But I thought it was clearer to just say like no collect. I don't know. Maybe not. All right, let's see. Oh, you know what? My serial connection could be down. For some reason, this like Scilab's thing stops working from time to time. Pretty quick. Stream is so hot, someone called the fire department. That's right. Well, I didn't crash, but it's not working. So this is where the debugger is helpful. Plug it in, fire it up, and see where we're at. We are in gc re-alloc. Hey, we're in an assertion. That's why we don't have anything. GC 1209. We asserted that the ATB get kind of the block is at AT head. So we're trying to reallocate something that was freed? No collect gets right to the point. Yeah. Yeah, it was weird. I like making the GC alloc flag no collect, but the allocation flag collect was a little weird. But are you using the Raspberry Pi debug probe for this? I am. I am. If I can, if my bench is my bench. Let me adjust. So there's my fruit jam. And here's my debug probe. And I'm kind of like plugging and unplugging it in as I need. All right. Yes. So that's my guess, is that we're trying to reallocate something that got freed. Oops. So scope find or add ID has this scope. And I wonder how see, I'm in main fatal error. So let's add a console print there too. Collect fatal error. We are in debug mode. Okay, so now we should print the message. Okay. Let's just try that. So I think this is a case where the outer object did not get collected, so the thing it pointed to was freed, but the outer object actually was still being referenced. So let's take a look. Hopefully Jim's not going to pop in and tell me why this is a bad idea. I see. I thought I saw Jimmo typing. Jimmo is a MicroPython developer. Okay, great. So we are at least getting the printout here that we failed in an assertion. All right. Gary says it's on my list to buy and learn. Yeah, it's very inexpensive. We're on our RP2350 boards. We're starting to put just the 3-wire plug. So that's nice and convenient. My son Taylor, former brief guest on your show, says hi. Hi, Taylor. Are there any tools built into CircuitPython that help identify where the freed allocation was allocated, assuming that there's an error in the flags that were passed to the initial allocation? I tried to add this. I tried to add it, and then it fixed my problem, I thought. But I could try to do it again. So what I had tried to do is anytime we were skipping a collect, we actually did do the collect, but we didn't mark the things. We just, yeah, let me explain. Jim, I'd love your thoughts if you have time to type them in. I'm not looking at your DM right now. So what I did is I said, should scan. I said true or should scan. So we always go here, and then I added this. If we verified a pointer, no, don't do that. And we said we shouldn't scan it, then we set the pointer null, trying to blank the pointer from memory, and then print out that we should have scanned a thing. So let's try that. Maybe it'll work this time. Instead of, the problem is we scan the stack, so you can actually hold on to objects longer than you want to. And you have to, I'm probably, the compiler is probably being smart enough and not setting it to 0. Serial console setup. So GC is slower even here, but we came up. So something we're doing, I could mark it volatile and that might trigger it. But doing this code alone, even though we're breaking out of this loop that then should mark things as free. Should have scanned a block. We are doing split heap. Oh, we're doing split heap. We're in the wrong branch. Okay, we were in the wrong branch. Okay, sweet. Because we always do. Watch for as long as the kids are interested. I'm trying to pick up context. I'll also never do GC work bare metal, only Unix port, so I go wild with logging. Yeah, I thought about it. So the pitch is that when we collect everything, and there's large buffers that we know don't have pointers in it, and we should know that so that we don't scan them. The context is that we're running on the Fruit Jam that it's an RP2350 with PSRAM, and we're throwing a bunch of bitmaps, in particular bitmaps, into PSRAM, and we shouldn't be scanning those for pointers because we know there's no pointers there, and they're like very costly to scan. So I'm trying to be whole hog on it and just like make all allocations either say they need to be collected or not, either implicitly or explicitly. But I'm getting into trouble. It's crashing. Should have scanned all these blocks, and then we break. Okay. So here's the first one, and we see that multiple times that we should have scanned it. So I think it's deterministic enough that if I go in here to gc.alloc, gc, yeah. And I say, that's my noisy neighbor. So I think I can say if mark area is not to be collected. So if area equals, we'll see if this works. Copy. And block, start block equals 361. I'm going to do an ASM breakpoint. And I think I'm going to have to cast this. So this will cause a breakpoint to happen when I'm connected with the debugger. This is kind of just where I discovered it. But I know it's kind of silly that I'm doing the whole load it on the thing. This basic stuff, I would tickle with the... There's lots there. At least my diagnostic's working now. Hi, Jim's kids. Welcome to Deep Dive. I'm sure you get a lot of this in your day-to-day life too. Okay. So we're in gc.alloc 103. Alloc no collect. So this is a push result node that needs to be reallocated. Hi, Skylar. Don't have a tool like that in MicroPython other than logging. Yeah, I haven't dusted off my like heap visualization in ages. But it could be helpful in this case. So push result node. Parse in 541. Yeah, I mean, this is definitely a case where they're like outer objects that are holding on to Python objects. Push result node. Parse node renew. Parse node. Free parse node struct. I think it's called alloc. Renew. Arrow? How's it allocated? Parse node. Free parse node struct. It comes out of these chunks. Parser current chunk. I thought I did the malloc with collect, I thought. New num bytes. GC re-alloc should know. Pointer in. This might be the death of this idea. Yeah, I did log all allocations and then post-process to draw a graphical image. It was years and years ago now. It was really helpful for understanding what happens. Did I mess up the GC re-alloc? This is the problem with having one be negated and one not be negated. Not CTB get, then alloc flags are that. I think that's right. A great education too to see memory, which can be hard to conceptualize. It's true. It's very true. I think it might be more interesting, well, running in emulators could make that more helpful. I don't know. Selective collect. That seems right to me. But if it's not... Oh, you know what? This parser might be this parse new chunk thing. No, it does the malloc with collect. This is annoying. So it's a re-allocation. Yeah, I think, let's try what Jim's saying that he does, which is clean. Trying to do it in the Unix port. So I think it has a GC. I guess I could have given it -J. Build coverage. I just had that in my history. It works. I don't know if the GC is active. I don't have any console logging. Oh, you know what? I bet I know what it is. I'm not turning the feature on in the Unix port. That's good to know that it works when it's off. Ports Unix, ports Unix. I did use mp config port. I've been talking about a lot of automated stuff. I did use Claude to do the initial changes. Selective. And all this autocomplete stuff is kind of coming from that world. Make clean, make J32. It doesn't build. Oh, because I added the breakpoint. Well, good. Now I know it's running that piece of code. So let's remove it. I didn't see how you're handling re-allocs. If you are shrinking or extending it, it doesn't matter because it's based on the first block. 506. MP printf. I think I am. Because I'm getting... Only if I'm going to move it do I need to copy the state over. So I say if selective collect is there, we get the CTB get. If it's false, then we also set the do not collect flag on the alloc flags that we pass into gc alloc for the new one. All right, we built, and let's try to run this random test again. It works. It works as well. Yeah, so Jim says, the parse nodes are tricky because they're block allocated. It gets messy quickly. Why are they block allocated? A lot of time trying to tune that and convince myself that block allocator actually helps. I think it does. In general with the GC, so many things that help, but the trade-offs aren't worth it. I'm interested to follow this because I think we can do something more useful with flags. My idea is that we use what is currently the finalizer flag and say this allocation has metadata, and then we do a lot more metadata at the start of the allocation. But come up with a way to also understand that if the allocation is an object, then we can use its flags instead. I was thinking about this, and I was thinking we'd put the metadata block at the end for any non-block sized allocations. Then you get the alignment still. I have a tool that monitors the output of mem info dump and traces that over time, but that wouldn't help here. Much more useful for fragmentation issues. The other thing is I'd rather just do TLSF. Like, TLSF is great. We should just use that for it and then just add extra metadata into the TLSF blocks. And then you get better allocation times and better... yeah, TLSF is great. We allocate so many of them during parsin, too expensive to allocate each individually. So the parser pre-allocates big blocks. Arena allocation, essentially. So this is because allocating to the heap is slow. But if you use TLSF, it wouldn't be as slow. Because TLSF is clever in how it finds a free spot. Well, it works. So it doesn't really help me. Doesn't help me debug this. Because the Unix port seems to work. It is somewhat different. All right, we've got 30 minutes. I'm gonna go back to Raspberry Pi and just do it that way again, even though it's kind of painful. I don't know what the TLSF overhead for a small allocation is. That could be a part of the problem. Okay, so I want to undo those last couple changes. Okay, and then I'm gonna, in re-alloc, I'm gonna put a print. See, look at it, false. It takes in. I'm gonna log here. Pure freeze, I don't care about. I want to know if somebody's using re-alloc to allocate. Thanks for humoring me with the Unix port. Because else we would try a 32-bit build and a much smaller heap size to match bare metal. But yeah, better keep moving. Yeah, I still, like, I added a renode port, and that would probably be a way to do it too. But pointer in. New blocks. What is the current block? Okay. That's not what I want. I mean, I assume it's just something that is not being marked as needing it. Okay, I'm going to clear this. And copy it over. Yeah, Unix, like instrumenting the Unix port is really what I should do. Because you could do cool things like spitting out trace data and stuff straight into a separate file. All these should have scans. All these 80 bytes, 320 bytes. So the first one is the area. I wonder if this is, I shouldn't care about the area, I should care about the pointer. It's probably easier to just use the pointers for the blocks. And then I don't have to do these two separate values. Right, so this should have scanned block. Okay, yeah, let me change that. Not very helpful. Pointer in. No. Stop that. There you go. Should have. It's not a block anymore. And like I said, it's deterministic enough that I could, the next time I can see where the original allocation is coming from. Oh, but you know what? My re-alloc could be even better. My logging here could be even better. Because you're right. Pointer in, pointer out. N bytes and N bytes. N bytes is the new value. Do we know the existing value? New blocks. No. Oh, N blocks is yes, we do. We do ish. Times bytes per block. That's close enough. Hopefully that'll be more helpful. All these blocks we should have scanned. But yeah, I am a huge fan of TLSF. Although I've found bugs in many implementations. Should have scanned null. That's not right. Oh, I'm printing pointer. Oh, but that's not right either. Oh, I'm setting it to null. Right. I'm still kind of in the like, are AIs actually helping me? Because I'm like, yeah, that's right. Oh wait, no, it's not. If we take in block, pointers, this is void pointer, pointers, block, pointer. I don't care about that. Block pointer. Pointer was always no because I was setting it null. All right. All right, we've got 15 minutes or so. I don't think I'm going to finish this today. I think that's a safe assumption. Okay, these look better. So we should have scanned this 11880. And it's this thing that we went from I wonder if in the re-alloc print, I wonder if we re-alloced it twice and we lost it? Or we could print allocations that we don't. Actually, let's just hard code a breakpoint here. So 19880 comes from AF70. AF70 comes from here, which comes from 930. And that's the start. So 930 did not get reallocated. That's the original number. So if we go into car stuff. Okay, in gc.alloc, right before we return it, if ret pointer invites flag, let's put flag, yep, yep. I don't know why you think I want to delete that. Ah. Yes, yes. Sorry. Okay. Am I in load mode? No. I do like this command. Run. Okay, so now we're in the, we had the debugger connected, so it hit the breakpoint. MP parse. 1058. Oh, is this the stack? I was thinking the stack. 1058. The result stack. M new maybe. M malloc. Maybe with collect. Size. We got to get a handle on all these different malloc helpers. And now, do you think it'll run? Yep. That's right. Okay, we'll see how many should collects we get. Do this. Any final questions for me? I don't even know if anybody's still watching. This is thrilling, I know. We're going to hit the same breakpoint, aren't we? Even though it should be fixed. Actually, you know, we could see. Since I left it in there, if we backtrace now, we can see that it is set to be collected now. And we are calling through maybe with collect. So we need to remove the breakpoint that we added to debug that particular allocation, which is in gc. Hey, now I wanted to delete it. DCD is here at least. Preemptive thanks to DCD, who usually takes time codes. I am curious, like, how quickly. This is great low-level programming information. Yes, if you wanted to know all about heaps, 80cc's loving it too. Great. Thanks for sticking around. We'll do 10 more minutes if folks have questions. Do you think it's going to run? Nope. But we should be able to do the same process now. I shouldn't have deleted that thing completely. what's the first should have scanned now? Moving, 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 moving. Good. Should have scanned this. 9B E0. I guess I could copy it and fine. Oh, weird. Do we allocate it again? I guess we should print the allocations. This is going to be the second time it's allocated, which is going to be annoying. Although I think I should have cleared it. Yeah. Like I said, at least it's consistent. Okay. Should have scanned. So that is another allocation. So it looks like it might be subsequent allocations. The other trick I've done for breaking points is that's the new address, right? Yes. Still partly here. I went back and got a better understanding of what you're doing. I talked about it a bunch with Jeff and Damien and Angus. I'll email it later. Okay. Hopefully I'm going the right path. Although I've only spent a day on it, so it's not too bad. And I didn't clear this, but here I should be hitting the allocation again, and I am right at the start. Reader new file, VFS reader 97. This is the one I think I already was here. Look. What? I thought mnew obj var was being collected. It is being collected. Can we continue? Yes, we can. Sweet. np compile. Compile 3691. Okay, I don't think I've done compile at all. $36.91. Compiled module. Make function from proto function. Compile to raw code, but it might need to be a root. Okay. So now if we learned anything, we go back to GC, comment this out. Otherwise, we'll still hang up, even if it's correct. I wonder if creating a refactoring design document would have cleared up for us what you had in your head. It's like you are your own maintenance program and you left a bug in there for future self to find on Monday. I think this portion of it is really hard, right? Because you need to know control flow, right? You need to know that, like, not only are you doing an allocation, but you're going to follow up by putting another pointer from the heap in there. That's like a complicated thing to know. And like, there's no intermediary that's like managing those assignments, so we couldn't add something that like as-built docs for all these major features. Oh yeah. I was trying to just add some comments about which allocators to use. Like, that would be more helpful. New is not helpful, right? So like, I did add in misc, is where I thought all of them were, but I added this comment. The following are convenience wrappers for malloc helper and can save space at the call sites. malloc and new allocate space that is not collected and does not have a finalizer. Use malloc items to allocate space for MP-obj2 that will be collected. Use MP-obj malloc to allocate space for objects, aka structs with a type pointer that will be collected. How does the GC work? Has been on my to-do list for 7 years now. I tried to explain it at the start. Okay, I'm gonna clear this and just let's see what the should have scanned says. It looks cleaner. All right, last one and then I gotta go. 19BE. This is the one we found before, but this is different now, right? Is this the one we should have been looking for? It wasn't reallocated, but let's do one more and then I'll check. Then I'll stop and then check it in for a day. That was right? No, I didn't have. Okay. Last one. Then it's weekend. I will push this into my leaf allocations branch. I guess that's what I was calling. Like I said, that's what I thought I was. When I thought of it this morning, I was like, that's what I should call it. But yes, if we were to put major work into how the GC works, I would just do TLSF. TLSF with like a larger metadata block. Because TLSF has good freeing and allocation properties. And I think you could still bounce between all of them. It's like kind of a linked list in memory too. But it doesn't have any, it has very little like global state. It's all, is that true? Yeah. I don't know, maybe you can't iterate through all of the allocated areas. Or maybe you can, I'm not sure. Okay, so this is, now we are in NP module context allocate tables. Okay. Number of queue strings and number of objects. BC305. Oh, yes. M new. What is it doing originally? MPU int. That's probably MP_t is what it should be. So my guess is this is malloc items. That's what I called it, I think. They're either going to be Q strings or they're going to be objects. Yeah, see, even down here I did it. I didn't realize emit bytecode uses QString table, but here I already updated it. Okay. And we got to update GC. Comment it back out. Make it again. I don't see any final comments or questions. I thought you started with just optimizing the large buffers, but I missed the transition to more extensive refactoring of the rest of the MPCP code. Yeah, I started yesterday prototyping with the large ones by just using port malloc directly. But what I tried to do today is was like anytime you call mmalloc or mnew, it doesn't get collected. Because there is this helper for allocating Python objects that is like most of the time the way that you do Python objects. Because you also want to set the type. It's just these weirdo like intermediary objects that obviously I missed. Hopefully. Hopefully. Because like all of the strings and all of the bytes you don't need to do either, even if they're short. And then there's like these big pools of strings for Q strings that we wouldn't need to do either. So, okay. Well, we still failed. Darn. So there's the print. Serial console setup. This is that other one. All right, well, it's the same process. More and more and more. Like, I wonder what all these things are. Should have been scanned. And that's not even necessarily true. These could be false positives, but... all right, thank you everybody for joining me. This has been another deep dive into the world of the lowest levels of, in this case, both MicroPython and CircuitPython. How memory gets managed by the VM. If you want to support me, you could go to Adafruit.com, purchase hardware there. The Metro 2350, I don't know if it's in stock, but it is available. Unlike the Fruit Jam that is not available yet. I should be here next week, I think. If you have any questions or stuff, feel free to find me on the Discord. Discord is the middle one here. You can go to the URL adafru.it/discord to join that. We'll be on there next week. I think I'm around all next week. I have like just under 3 weeks left, I think is what it is. So, and then I'll be on leave. And then I will be back in the new year full-time. Once the youngest child goes to daycare, I'll be back full-time. But until then, I will be either off completely or partly around, is the current plan. Subject to change, we'll see. Anyway, yeah, support me through Adafruit, adafruit.com. Thanks to them for all dealing with all of this tariff stuff. It's really wonderful to not have to worry about it myself. Although I did buy a car because of it. Besides that, preemptive thanks to DCD for timecodes, and thank you to Tim, Foamy Guy, for filling in for me otherwise. And thanks for everybody in the chats. It's wonderful to hang out with you. See ya. Have a good one.